Okay, so here's a couple of examples of completing the square. So let's do the first one. So first thing, okay, I've got my equation ax squared plus bx plus c. So I'm going to take half of b and I'm going to put it into a bracket with x and square it. So I've got x squared plus 2x minus 5. I'm going to take half of b, which is 1. X plus 1 all squared. Okay, now I'm going to expand and compare. Okay, so if I expand x plus 1, I get x squared, x, and 1. So that means that x plus 1 squared is x squared plus 2x plus 1. And I'm going to compare it to the original equation, which is x squared plus 2x minus 5. Okay, so x squared, that's fine. 2x, that's fine. Plus 1 minus 5. So the one on the left, the x plus 1 squared, is 6 more than the original equation. So there, now, the last thing I have to do is find the difference. Okay, so the difference is I've got to take off 6. So that means to complete the square, I have x plus 1 squared minus 6. And that is equivalent to my original equation, but in the completed the square form. And that means, remember this, I flip my sign, and that gives me the x, and this gives me the y of the minimum or the maximum point. Now here, because x squared is positive, it's going to be a minimum. Let's have a quick look at the graph. Here it is. So we can see the minimum point here is at minus 1, minus 6. And we get minus 1 and minus 6. Okay, let's look at another example. Now in this example, a is not equal to 1. So when we have ax squared plus bx plus c, the a is not 1. So first thing I do, I'm going to factor out a. Okay, so got my equation, 2x squared minus 12x plus 5. I'm going to factor out a, which is 2. I'm going to put brackets. Now, 2 times x squared minus 2 times 6x. Right, okay, so what did I take out that factor of 2 from the 2x terms? Okay, now I'm going to take half of b and put it into the bracket just like we did before. Okay, so x squared minus 6x, so half of b is 3. So I've got x minus 3 all squared. Now I have to subtract b over 2 all squared, because I had x squared and minus 6x in the brackets. If I expand x minus 3 all squared, I'll get x squared minus 6x plus 9. So I'm going to subtract that 3 squared. So I'm going to subtract 9. Okay. Now I'm going to expand the brackets. Okay, so I do 2 times x minus 3 all squared and 2 times minus 9. So I get 2 times x minus 3 all squared minus 18, and now I've got the 5 on the end. And the last thing I need to do is combine the constants at the end. So I've got 2 x minus 3 squared minus 18 plus 5, that's minus 13. Now, important thing, this does not tell us about the minimum point. The minimum point, we switch the sign, and that's my x, and this is my y. So you can see that the minimum point should be 3 minus 13. And let's just double check by drawing the graph. So y equals 2x squared minus 12x plus 5, and we get our minimum point at 3 minus 13, just as we expected, 3 minus 13. Okay, the last one is 5x minus x squared. So again, just a slightly different example again. So I've got no b term. Okay, there's no term in the middle. So I've got 5x minus x squared. Okay, well, I can't do what I did before because I can't take half of x, so half of b, because there is no b. So I'm going to factor out x. So I get x times 5 minus x. Okay, well, this is the same way that I would solve it to find out what makes it equal to 0. So now I know that this will cross the x-axis. The roots are, it will be equal to 0 when x is equal to 0, because 0 times anything is 0, or when this bracket is 0, which is when x is equal to 5, because anything times 0 is 0. So x is 0 or 5, those are my roots. So I know that my line of symmetry is halfway between my roots. So 1 at 0 and 1 at 5. Now, this has a negative x squared, so it's going to have a maximum point. So our maximum point is going to be somewhere up there between 0 and 5. It's going to be halfway between them, because it always is. So x is equal to 2.5. That's going to be my line of symmetry. So my maximum point is on that line. And I know if x is equal to 2.5, then y is equal to 5 times 2.5 minus 2.5 squared. So the y is equal to 12.5 minus 6.25, which is 6.25. And again, if we look at this, a graph of this, this will show us whether we're right or not. So y is equal to 5x minus x squared. There we go. So we've got an upside down, a frowny quadratic. And you can see that our maximum point is here at 2.5, 6.25, as we thought. Hope that helps.